looking at options, right? If we divide first, that's what happens. If we subtract 34 from both sides, that's what happens. If we add 21 to both sides, in C it shows what happens, and then D just suggests leaving moves. So we have our methods that we used in class, but if we have 34 equals 5x minus 21, what is your main objective here? You with me on that kind of? What's our main objective? Like, what are we really always trying to do? When it tells us like solve. Solve what? Solve for x, right? And to solve for x, because that's our variable here, we got to get it alone. What's the most, they're asking what's the most efficient first step to get x alone? And you can't get it alone in one step, but what do you think? Do you have a guess? Anybody want to weigh in most efficient first step? A, B, or C? Do we get rid of the 5, get rid of the 34, or get rid of the 21? That's really what we're asking. Alex? Move the 21, right? Get rid of this because we want to start isolating that. So the most efficient way to start is add 21. That takes us to this. 55 is equal to 5x. Then the last thing we need to do to isolate x. Somebody not on what's yeah, Eleanor? Divide each side by 5. And we get x would be 11. Now, none of the other ways are wrong, but they're not great. They're just a little bit more complicated. Get some stuff out. You look like you're ready to learn. Come on, man. You look like you're ready to just observe. Anything else before we dive into the lesson? Because today we're talking about like best strategies. So if you worked on last night's homework a little bit, today's lesson will make a whole lot of sense for choosing best strategies here. So there are, if we're being honest, the thing that makes math really hard, at least for me, and this is like a personality thing, is making choices. I'm really bad at making choices, which is why I'm really good at being married, because I just get told what to do. So, marriage joke. You guys don't get it, you don't appreciate it, but someday, maybe you will. So Nick tried to use a symbolic method to solve this equation. He made a mistake, or he potentially made a mistake. We got to check it for him, right? What do you think? Are we good? You can weigh in. Tell Nick if he's right, he's wrong. If you're struggling with this process, it might be beneficial to write down Nick's process. That would be a good reminder. Alex, sorry that your hand's up, man, but I got to check in with multiple people. All right, Francesca, what do you think? First thing he did on both sides was add 6. Is that what you would do? Yeah, okay. Why would you make that choice?
Well, you would get rid of 6.
Yeah, we get rid of that subtraction by 6, right? So, if our goal is get the x alone, start getting rid of the other stuff. So his first step, absolutely perfect. 27 plus 6, his addition is correct. So then he's got 3x equals 33. Liam, what do you think about his next step? So he took his 3x and did this on both sides. Is that what you would do? Yeah, because to isolate x in a situation that has 3x, we divide, right? What's that called? Those two words, we're kind of doing the backwards process. If it's multiplying, we divide. If it's adding, we subtract. It's the reverse. Yeah, inverse operations. Saw Allie's light bulb turn on. Some of you guys just won't speak up, and I encourage you to find your voice and speak up. Try this on your paper. So we want to check out this situation. Nick represented this with algebra tiles. If you'd like to grab some algebra tiles, you are more than welcome to. But this is the equation that we have. So go ahead and write that equation on your paper. 3 parentheses 2x plus 4. What does that mean? Who could like say that in a verbal sentence and kind of explain to us why this is written like this and how Nick showed it right here? Who can explain why Nick showed it like he did? Like he didn't just throw the tiles on there, he kind of arranged them specifically. Grant?
He arranged them in a way to show that both 2x and 4 will multiply by 3.
Because we can really say that this tells us 3 sets, right? Or 3 groups. And each group, 2 x's and a 4. Or 4 ones. Any questions on why our mat would look like this? Anybody want tiles to play? They just take a little bit longer, so I think most of us are kind of getting beyond that. So if we have 3 sets, Patrick, what would you think about doing first here with that equation?
Oh no, I forgot the operation, but you multiplied 3 by the 2x and multiplied 3.
Starts with a D. Do you remember?
Distributed, yeah.
Distributed property, right? We could, now, don't write this down yet. We could do this. But visually, something has been done that makes me curious. On the left side, Nick has his mat split up in 3 parts, right? Take 30 seconds and try to talk to the partner about how that might help us solve this equation and avoid distributing. Try it out. 30 seconds. Totally can. We're not actually subtracting. So these would multiply. You can't just put it in well, we're going to avoid that because I'm going to avoid working with that part. All right, that was actually 45. Sorry. Mr. Hopkins, any ideas back there?
We said we could subtract 3.
Subtract what?
3 from.
We cannot actually. This is multiplied, or it's trying to multiply. You cannot subtract that. Hello, what do you think? We cannot actually. Grant?
The left side of the mat is divided by 3, so let's divide the right side.
If he has 3 sets over here, can we split up the right side into 3 sets? Give me your eyes for a second. Don't write anything. And exactly what Grant just said is the math that we do instead of multiplying, which then we'd actually have to undo later. Just divide by 3 and only look at one of the sets in the problem. So show on your paper that we're actually going to divide this, and we're going to only look at one set of 2x plus 4. So what does one set equal, actually? Al? -2. Now I'm going to show the other way and then take questions if there are any. The other way, some of you were trying to do this at your desk, and that's fine because you can do it like this. If we distribute, we'd get 6x plus 12 equals -6. We then would have to get rid of this plus 12, right? So we'd minus 12 from both sides. we'd get 6x equals negative 18. What would we do then? Divide by 6. And we get x is negative 3. Over here, we didn't distribute, right? Instead, we divided. So this would be the method if we had taken the distributive property. What do I do now right here? Matt, what do I do right there? Yeah, get rid of the 4, so we do what to get rid of it? Yeah, subtract inverse operations there. We get 2x is negative 6. What's the last thing we did? Anybody? Divide by 2. I am not here to convince you of anything. I am just here to present options. Either of those routes gets us to the same place, right? So I'm not here to tell you that the best way to get from here to Florida is take the direct route south, because if you decide to go to California first and then come back over to Florida, you'll still get there, right? We have a destination we're trying to get to. I don't really care that much about how you get there, but there are ways that are easier and quicker and ways that are a bit more difficult and a bit harder. It's up to you. And that's one of the hardest things, is choosing that strategy. Any questions on how or why we did what we did? Because then you're going to try it on your own. You're going to need that pencil. Liam just lost his pencil in his hair. So, try this out. I want to see how well we can pick apart this problem. Be careful because they're talking about area. So work on this with your partner for a minute. what's your real question? Who are they for? What gets referenced here, right? We're trying to pick out what do I use for the variable in the problem. We're looking for what gets referenced. Emily, what do you think? What gets referenced here? Okay, so that they directly give me that though. So that's just like presented, not really referenced. So we know the area. I guess I can jot that down somewhere. Area is going to be 108. Right? We know that. They tell us you should write that down. Area is 108. That's information we know. Now we also know, since it's a rectangle, area is length times width. That's also worth writing down, because we know that. But Emily, if we're trying to choose a variable, guys, general reminder for everyone, you can always pass. I just go through the cards so I chat with everybody. What gets referenced? Do we reference the length or reference the width? What statement references the width?
The length is 3 feet longer than the width.
Yeah, this statement right here, that's where we reference the width, right? Length is 3 feet longer than the width. That's where we reference it. So what are we going to choose as our variable? We're going to represent width with a variable or length with a variable? Anybody? Grant? Since this references the width, that's what tells me, hey, make width W, or whatever you want to make it. So width is going to be W. We just say W is W. How do I represent length? Eleanor, what do you think? W plus 3, because it's 3 feet longer than. Any questions on how we chose variable or set up W plus 3? So then, what do we have to do with these expressions? Has anybody figured that out?
You double them because there's 2 lengths and 2 widths on each one.
You're falling into trap. Hopefully you can still climb out. There's a ladder, don't worry. What did they give us in the problem? What number did we write down? What did it? 108, but what was that?
The area of the group.
Not perimeter. Right? Area is not perimeter. So we know, and we have written down in our paper, that area is 108. We also know the area is length times width. You've got your length expression. You've got your width expression. Now, somebody just said, so you multiply them, right? So if I write area equals length times width, I can replace area with what? 108. Please make sure you're doing this on your paper. I can replace length with W plus 3. And I can replace width with W. Now, this gets a bit tricky. Anybody know what I need to do? Penelope? What if I rewrite the right-hand side? Alex? So what are you telling me to do? That is the right answer, but what process? What's the word that we use? We distribute. Even though w's not a number, we distribute the multiplication. So guys, it might help you on the right-hand side to actually turn around where the w is. But you can actually distribute from the right-hand side. It does the exact same thing. You just draw the arrows the other direction. So what Alex said, we get 108 equals w squared plus 3w. Well, that's really weird. That gets into math that you guys don't quite know how to solve yet. And that's okay. But that's the process that we take to work our way there. I'm just going to leave this for us to come back to. I want to make sure we get through another couple things in class, but that is the process. Now, if we 5D, because I was going to come back to this, but let's talk about this for another minute while our brains are on it. This is math we don't know how to do, right? This whole squared and I'm going to move this for a minute. You just go over there. This is kind of an easy question because it was in the problem. What's a process that we've learned to deal with really hard stuff where we just kind of guess and try it? Yeah, but what do we call it here? 5D process, right? So if you think about your 5D process and you set up a little 5D table, we are referencing the width, right? And then we have width plus 3. And then we have area needs to be 108, which we do by multiplying the width and the length. So length is longer than width, right? So if width was 10, what would length be? 13. Would that work? What's that give you? 10 times 13? 130, right? Too high. Somebody give me another guess for width. 8. Okay, sure. I like it. Drop down by a couple so we can kind of start to box it in. What would that make the width? 11. 8 times 11, 88. So that's too low, actually. So now we try, anybody? 9. That makes the width. Yes. Alan says yes. So guys, we don't know how to do this. This is called a quadratic equation. It makes something called a parabola. They have points called zeros and a maximum and a minimum, and all these things you don't know about yet. But if we use the process that we do know and use our mathematical skills of comparing, if I guess this, I can figure out that, and then I can do this. It doesn't matter if I'm right the first time. I tried. This only took us 3 tries. You guys might actually get this faster in my high school math 2 class, doing the quadratic. Now, if you want to look at this, come talk to me later. Quadratic equations are fun. And they're not hard to work with once you understand them, but you got to understand them. Questions? Like most of you don't care about this. I'm sometimes curious how long I could stare at you guys before it would just get too awkward and one of you would say something. I often feel like some of you have questions or you want to check something, or you're just staring at it it's not that obvious yet. Try this on your own. We have a triangle, and it gave us a partially completed 5D process. How would we write this, the information presented in a word, a word situation? Given a triangle, we know that one side is da-da-da, the other side is that. talk with your partners. How would we write this out? And how can we help them finish their 5D process? Because actually, this equation that we have, we can deal with. We do know how to deal with that. You don't have to use the 5D. Here, dealing with the equations is the best way. So try that out with your partners. Try to write first the verbal situation and then work to solve it.
Can you describe the situation in words? Like we have a triangle and do that? But what is still on the left hand side of the screen? Yeah. So we can write 3x on the left hand side.
It's pretty subtle.
Is anybody confident enough to give me the problem as like a sentence? Like a description. So not like a sentence, but like a description. Ella? So I'm going to write a really shorthand version of what Ella's telling me. So side 2 is 2 meters longer than side 1. Sorry, I don't have space to write side. Okay, continue. Does everybody get how Ella said side 3 is 4 more? Because this, 5 plus 2 makes the 7. The 7 carries over into side 3. Side 3 references side 2. That then, give me your eyes real quick, makes this look kind of funky. Because they plug in just like we did on those word problems that you guys presented. X plus 2, that's my side 2, and we add 4 to that to get my side 3. So we could also really just say side 3 is how much more than side 1? Yeah, we could just say side 3 is 6 more than side 1. If you want, you could rewrite and kind of change the descriptions. Very good. And the perimeter is 35, right? That was part of the problem. Perimeter is 35. So as I walked around, I saw a lot of people had, and if you don't have this, please go ahead and write it out, the equation form, right? X plus 2 plus x plus 2 plus 4 equals 35. If you don't have that written out, please write that out. Zoe, at this point in our process, what do we want to do? It says 3 magic words that make everything easier. And what are like terms? What do I get when I combine my like terms? Like how many x's and how many numbers? Yep. 3x plus 8. So we have 2, 2, and 4. So we get 3x plus 8 on the left-hand side. Any questions how we got that? That's going to equal 35. Then, Renard, what do we do next? Yeah, subtract the 8. And that gives me 3x is 27. Glad you guys are good at math. And Kate, what do I do last? Divide. Now be careful. Divide by 3. We don't divide by 3x. We just divide by 3. Sorry. X, I should make it not look connected, is 9. So, hold up. What if they ask you for all 3 side lengths? We have 9 and then 11, because you got to add 2, and then 15, right? Those would be my 3 side lengths. Shortest side is 9. Add 2 to get side 2. Add 4 more to get side 3. Questions? I don't know what this is. Nice. You want to try one having to do with bees? You know they now make indoor beehives that you can run a hose out to your out your window.
Oh,
So you have it's like a hexagon, and it's got so you can get honey out of it. It's kind of cool. Google it if you want to. Google it. Indoor beehive. Now I'm just terrified that my dogs would knock it off the wall. All right. So can anyone pronounce that word? That word. Apiologists. Yeah, probably apiologists. So apiologists have found that the number of types of bees, ladies, come back. The number of types of bees in a hive is based on the amount of nectar and pollen available, which makes sense, right? Food. Where we have food, we have a lot of types of bees. So within a hive, there are 3 types of bees that help the queen: workers, drones, and nurses. This is true information. Yeah. Yeah. Yep. This
Like the nurses that actually help.
Yep. They wear the mask and the stripes and I'm making jokes, but they do have stripes. We're talking bees, right? So, in a recent study of a hive, and they do this stuff, guys, because bees are important for all of our plants. Like everything you eat, bees are important. So, there was a total of 4,109 bees, not including the queen. Okay, forget the queen. We don't want to touch the queen. They get mad when we do that. There were 33 more nurses than drones. The number of worker bees was 12 more than 6 times the number of drones. There's a lot of worker bees. The number of workers was 12 more than 6 times the drones. You got 8 minutes. I'm not going to give you that whole time. We've got 8 minutes till the end of class. So you've got about 3 to 4 minutes to try to set up our expressions for each of these. All right, so we have nurses, drones, and workers. Nurses, drones, and workers. How do we express what we've been told? And then how do we work with it? So take a couple minutes on your own. Try that out. And remember, guys, you can write one expression and then change it and like plug in something else. You can have multiple expressions that represent the same thing. So you might write one expression here and then change it and plug something else in. I know that's what I'm doing. Nathan, how could I write an expression for nurses? I agree with you. I'm going to use D, though, because I like using the things that kind of match the problems. So if we say D plus 33, nurses are 33 more than the drones. Ooh, so just leave that for a moment, the number of drones. The next thing it tells me is the number of workers, right? Come on, or not. How would I write the number of worker bees? Yeah, now I'm going to turn that order around a little bit. I'm going to say 6D plus 12. I may not actually need to put any other equation, because right now, I'm using the same variable for both of these. Right, they both use D. So, Aubrey, if I go back to look at representing drones, what does this D represent? What does this D represent? We just represent drones with D. One of my items that's being described is going to get the variable. Right? Whether I make the variable to match, I could have made that X, so it's a little bit different, but I like it matching. What else do we know? Marvin, what else do we know? What else did the problem tell us?
And the total amount of bees uncompleted 4,100.
So then, Allie, what do I want to do? Sorry, what was that? Yeah, set up the equation. So we know that all of them together, so D plus 33 plus D plus 6D, that's a D, we're running out of time, equals 4109. I need to be in a smaller marker. What do I do then? Delaney. I got the whole equation set up. What do I do?
So would you minus
No, trying too hard. Before you ever start doing stuff on both sides, we always check if we can.
Oh, because that's
No, not yet. Combine like terms.
that one.
D, another D, and 6 more D. What do we have?
8D.
8D plus, not 80, 8D plus 45, right?
Yes.
Then, anybody?
We minus 45 both sides.
Minus 45 from both sides. Then, guys, you should be writing this along with me.
4,064.
Then,
We divide.
and then,
D equals 508.
5 what?
508.
Hold up. We still got a little bit of time. Questions on what we did, because this is exactly what your mastery is going to look like. It's going to give you word problems. You're going to have to set up expressions, and you're going to have to put them together to solve the problem. Questions? I can stare at you until it gets awkward, but I don't think that'll work because it's the end of class. So, please do your homework. Tomorrow's homework is going to be whatever you have left from the closure. We're going to spend tomorrow's class time working on closure problems with our groups. So, if you want to get a jump start, you can check out the closure and work ahead on your homework, but I know we have a busy night tonight. So, thank you guys very much. I will catch you later.
Push that back in.